Assalamu alaikum. In this video, actually, I will be explaining a bit confusion about this example 4-3. This example is about the position analysis of a 4-bar slider crank linkage, and here actually a student reported me in class that he was finding confusion or some misunderstanding about this fourth clause in the solution of this example, that how these formulas have been applied. So I will be explaining that here important thing is that here the author has used two formulas, these theta 3 1 and theta 3 2. So here is one typing mistake which is clearly, which I have verified, that at least here this cos inverse is wrong. Remember, this cos inverse is wrong. Actually both of these formulas are actually sine inverse. So these are sine inverse. There is no formula like cos inverse, neither in derivation nor in this example. But still, what I want, that I will be reading this fourth clause, that find the two values of theta 3 from either equation 4.16a or 4.17. So what the author want to describe here, that he actually states that as we can observe that we have calculated the two crank positions. We have calculated the two crank positions for a given slider position. As we can observe, the slider position is given here, that D is equal to 100 millimeter. So that means the slider is input or slider position is known, and it is toward the positive x-axis. Remember that the origin of the coordinate system is always at the crank grounded pivot, means on O2, and y-axis is upward positive and x-axis is right positive, and here it is also shown x-axis. So that means the offset is in the negative direction, because here it is shown minus 20 millimeter. So that means that is negative. So actually what the author states, that find the two values of theta 3 from either of equation 4.16a or 4.17. So we first of all see what are these equations. We observe that these equations 4.16a and 4.17, these equations, if we go backward in the previous article, here these equations were derived. 4.16a, this is actually giving the connecting rod position, for theta 1 value, and equation 4.17 gives the connecting rod position for the cross loop or the second circuit. So actually these equations were derived for the case of crank slider circuit, means crank was the input and slider had two locations. So actually what the author wants to explain is that because these formulas were derived for the crank slider linkage, so the slider had two locations. So but now this example is actually for the case of slider crank, means slider is in the input and the crank has two locations. So actually what the author wants that for two positions or two angles of cranks, there can be two possible locations. There can be two possible locations for the same offset, means minus 20 millimeter, means this slider can be on the right hand side of this O2, or this slider B can be on the left side of this O2. So in a when the slider will be located on the left side of this O2, means ground pivot, so these angle or positions of the connecting rods will also be changed. So actually the author wants that we must locate the correct orientations and positions of the connecting rod. So that is why he states that we should find the theta 3 values from equation 4.16a and 4.17. So what we will be doing, that we will be calculating the theta 3 values, means we will be using theta 2 value, means when we will be using theta 2 for open circuit, for this red circuit, we observe that slider can be at this location, or the slider can be towards this left orientation. But as the position is given here, that D is equal to 100 millimeter, means this is toward the positive side. So we will actually be determining those values of theta 3 of the connecting rod, which will give the correct value or positive value, positive position of this slider, means toward the positive x-axis. So the values which will be given, the values of theta 2 for open circuit or theta 2 for this cross circuit, which will be giving the theta 3 values, that will be locating this slider B toward the left orientation, they will be treated as wrong. So actually the author wants that we should be testing all the values. So I have solved this example, this class 4. So here I can show here, as we can observe that if we use equation 4.16a is this theta 3 1, which is equal to sine inverse a sine theta 2 minus c by b, and 4.17 is actually, and we can again observe that this is actually theta 3 1 if we consider the example of crank slider example, previous example, in which 4.16a actually gives this angle and 4.17 gives this angle, which is actually pi minus theta 3 1, pi minus theta 3 1, because this angle where the cursor is located at this instant and this angle are actually same. So that means this angle is actually theta pi minus theta 3 1, which is actually equal to theta 3 2. But we can observe that theta 3 2 is measured along negative x-axis in the anti-clockwise orientation, whereas theta 3 1 is also measured from positive x-axis in the anti-clockwise orientation. So actually we will be determining the correct location of the slider. So as the author has stated that calculate theta 3 with both the equations for one value of theta 2. So we will be following the same statement as the author says, that we will be calculating theta 3 values, means the position of the connecting rod, using both equations of 4.16a and 4.17 for one value of theta 2, means theta 3 values will both theta 3 values will be calculated for theta 2 1 positions, means this position of the crank, both positions of the connecting rod, means on the right hand side when the slider is on the right hand side, and when the slider is on the left hand side, both values, both locations of the slider will be calculated, or both locations of the connecting rod will be calculated. And after that, those values of the theta 3 or slider location will be accepted, which will be giving the correct location of the slider towards the positive orientation from this crank grounded pivot. So as we can observe here, that for theta 2 1 theta 3 from equation 4.16a is calculated to be 29.887. so as we can observe that this angle is actually from positive x-axis. This angle is from positive x-axis in the anti-clockwise orientation. But here, as we can observe, for example, if we are observing this correct location of the slider, we can observe that the angle between this positive x-axis and this location of the connecting rod, this angle is actually not equal to 29.887, because it is obviously greater than 90 degree at least. So here, as we can observe, this angle is actually, correct angle is 150.11. so that means this equation 4.16a is not giving the correct value. So again, if we calculate same for theta 2 1 the theta 3 values from equation 4.17, the other equation, so we observe that the equation 4.17 gives the other value 150.113, and as we can observe that equation is actually giving this correct value of theta 3. So in this way, now we proceed toward the that we calculate for theta 2 this theta 3 value from equation 4.16a, as the author has stated in the example, that we will be calculating theta 3 with using both equations for one value of theta 2. So now use theta 2 for this cross circuit to calculate theta 3 for the slider when it is located toward the right direction and when it is located toward the left orientation, and then decide the correct orientation of the slider, correct location of the slider, and correct orientation and location of the connecting rod. So as we can observe, theta 3 from equation 4.16, that gives actually minus 7.267. so that means this angle is actually from the positive x-axis and in the clockwise orientation, because the angle is negative. So here if we see the actual example, we can observe that the angle from this positive x-axis toward this location of the connecting rod, because this is the actual location of the connecting rod, So this angle is if we observe that the amount of angle from this positive x-axis up to the location of this connecting rod, up to the location of this connecting rod, is never equal to this value of 7.267, because obviously this angle is greater, which is practically here this angle is actually greater. So that means this angle is also incorrect. So equation 4.16 is giving incorrect value. So if we calculate theta for theta 2 2, means the angle for the second location of the crank, means for this location the other value of theta, the other value of theta 3 that we can observe here, that theta 3 from equation 4.17, which actually comes out to be 7.267 plus pi, which is equal to 187.267 degrees. So as we can observe that this angle is actually correct, as this angle here from this positive x-axis and measuring anti-clockwise up to this location of the connecting rod. So as we can observe that only equation 4.17 is giving correct locations of the connecting rod and the slider locations. So now actually the author gives another check that once the values of theta 3 have been calculated against each value of theta 2, mean theta 2 1 and theta 2 2, so we will be using those values. Then it says then use equation 4.16b. What is equation 4.16b? That is actually giving here, I can show that equation 4.16b is giving the corresponding slider location. So we will further be inputting those values of theta 2 1, means for open circuit or upper loop, and the corresponding values of theta 3 on the right hand side or on the left hand side, and those values which will be giving the correct slider locations, mean D towards the positive orientation of the x-axis or towards right, those will be accepted. So actually this is the approach of the author. So I have also done here that now we will use equation 4.16 to match the correct value of D, i.e. the slider position. So if we use equation 4.16b and this is the equation 4.16b as shown. So now we use use theta 2 1 and theta 3 as obtained from equation 4.16a. So because that was actually incorrect value, because that was giving the incorrect location of the connecting rod and the incorrect position of the slider. So when we input the values, we can observe here that the result is D is equal to minus 108.08, which actually shows the slider location toward the negative x-axis, which is wrong. So that means, so this value of theta 3 is not acceptable, so we will be omitting that value. Again, if we use theta 2 1 means upper circuit and theta 3 value from equation 4.17, and when we input that value, So this will be giving the correct value. D is equal to 100 toward the positive x-axis, which is correct. So this value will be accepted. After that, again we test the for lower circuit for theta 2 2, that theta 3 from equation 4.16a, as we can observe, this is giving the value of D minus 138.07, so which is incorrect and wrong, because it is giving the location of the slider towards negative x-axis, which according to the example is not correct. So that means this value of theta 3 will also not be acceptable. So if we use theta 2 2 and theta 3 value from equation 4.17, so as we can observe here, that D is equal to this, and the result comes out to be exactly 100 millimeter, so which is correct. So that means that values of theta 3 from equation 4.17 give the correct angles and locations of the connecting rod, so these values will be accepted. Here I have shown and plotted the value for this, and as we can observe here, that this is theta 3 from equation 4.17 for theta 2 1, means for this upper circuit this is x-axis, this is not cross, so this value is also acceptable. And the other value from equation 4.17, it is giving this anti-clockwise orientation for the other circuit or the lower circuit. So both of these values are correct, and they are giving the correct slider and connecting rod location. So important is that we will be observing that the correct connecting rod angles measuring along x-axis in the positive orientations, means anti-clockwise, those angles will be considered, and they are very very important. So both of these criterias are equally to be tested, means the correct orientations of the connecting rod and correct locations of the slider, because the slider location is actually given and it is actually the input. So we will only be accepting or calculating or using those values of theta 3 for the connecting rod for both the open and close locations of this crank, they which will be giving the correct values of the slider and the locations of the connecting rod. So here we can observe the incorrect values have also been plotted, that this is actually the value of the theta 3 from equation 4.16a for theta 2 1, means upper circuit. So this value which was actually shown here, here this value, so actually this was actually giving the theta 3, means the connecting rod location along negative x-axis, means that actually value here I can show again, that was measured from the this positive x-axis, positive x-axis in the anti-clockwise direction, and the other value this is actually shown here, sorry, this value, that minus 7.267, which actually was calculated from equation 4.16, and this value is actually in the clockwise orientation because of this negative sign, and that is shown here, that this value, means this is positive x-axis, and in the clockwise orientation this is minus 7.267. so this is the theta 3 value calculated from equation 4.16 for theta 2 2. So because these both give incorrect slider locations and connecting rod, so these are not acceptable. So actually this was the uh, explanation of this fourth clause. So I hope you have understood. If you have still any confusion, you can ask. So I hope this will be helping you in solving this example, and there shouldn't be any confusion. And remember again that this cause inverse is quite wrong, so don't use it. Simply if there is some practical problem you are given, so what you will be doing, that you will first of all be noting the location of the slider. If it is in along the positive x-axis, so you must actually locate the locations of the connecting rod, and only consider those values of the connecting rod locations which are actually giving the correct slider position. So those values which are not giving the correct slider position, those values will be omitted. So this was actually the statement by the author, that we will be checking theta 3 values from both the equation 4.16a and 4.17, and uh, both of those values against for both positions of the cranks, mean theta 2 1 and theta 2 2. So I hope uh, you haven't any confusion yet. So thank you. Assalamu alaikum.